Alrighty, this video we will be working some example problems for polarization. So polarization, we learned last time that light, being electromagnetic radiation, is composed of an electric field and a magnetic field oscillating together, perpendicular to each other, as a transverse wave. And polarization is that characteristic which is described by the direction that the electric field oscillates. So again, it's an arbitrary choice to call the electric field's oscillation direction the polarization, because we could have chosen a magnetic field. But for whatever reason, electric field's direction was chosen, and we say that if, for instance, we have light ray oscillating like that, moving to the right, and so the electric field is oscillating up and down, then we would say the polarization is polarized upwards or up and down. It's the same thing. If it's up, then you know it's up and down. If the electric field were oscillating left and right, then we would say the oscillation is to the left or to the right or whatever. Now, it doesn't have to be up or down or left and right. It could be at an angle. And so what we want to do is figure out, for instance, what is the direction of polarization of light? And furthermore, as light propagates through different materials, let's say polarizing lenses or filters, how will that polarization change? So we know that if we have a polarizing filter and we send light through, if the light, let's say, is polarized upwards, and the polarizing filter is polarized upwards, then 100% of the light will get through because none of it is blocked. The polarizing filter blocks light, and it only allows that amount of light which is polarized in the same direction as the filter. So if the light is up, the polarizing filter is up, then all the light can get through. Whereas if instead light polarized upwards tries to go through a filter that's polarized horizontally, then you have none of the light will get through. It's all blocked because 100% of the light is polarized up, and only the light which is polarized horizontally can get through. But what if we have light polarized up, and we have a filter that's not polarized up and down or left and right, but rather at an angle? Let's say 30 degrees. That's where kind of the weird part of polarization happens. It doesn't mean that since it's polarized up, but only this 30-degree angle can get through, that none of it will get through. Because we can say that there is some component of that light which is in this new direction, this 30 degrees direction. And so we start to do, the components as if we were doing vectors again. And there's a bunch of math behind it, which we don't have to worry about right now. But at the end of the day, the amount that gets through is the law of Malus, or Malus law. The law of Malus says that the intensity which gets through is equal to the starting intensity of the light times the square of the cosine of the angle. And this angle is important to note. Theta means the original angle minus the filter's angle. Okay, or the difference between the angles. So if you look at this example, the original angle is up, that means 90 degrees. And I'm trying to go through an angle that's 30, then what I would say is it's cosine squared of 90 minus 30, which is 60. I don't put the angle of 30, which is what the filter says. It's always the difference between what is the angle of the light currently minus what's the angle that you're trying to go through. It's the difference in angles. And that's law of malice. If you want to know how much gets through, then you say, okay, well, how much intensity do I start with? And then I multiply that by the cosine squared of that difference in angles. And then if I have multiple filters, I just keep multiplying by the cosine squared of each filter. So that's what we found last time. Here's an example. Let's do an example where we have light polarized up. And I want to go through a series of polarizers. And I want to know, assuming I start with an intensity of I, okay, I don't care what the number is, it's just I want to know how much, what is the intensity of light that gets through this system of polarizers. So the intensity that gets through is the starting intensity times, I'm going from 90, and I'm trying to get through a 90 degree. So that's cosine squared of 90 minus 90, which is 0. Once I've done that, I've now gotten through this polarizer, and I'm now polarized upwards. I'm polarized however this filter says I should be. So forgetting what I started with, once I get through the polarizer, I'm now in that direction. Okay, so now I'm at 90, and I'm trying to get through 30. So I have another cosine squared. 90 minus 30 is 60 degrees. And now I could plug all this in my calculator. Cosine squared is just 1. Cosine squared of 0, is 1. And cosine of 60 squared is 0.25, so I have 0.25 I. That's how much gets through. So whatever I started with, 1/4 of that remains after going through these polarizers. Let's try another example. Let's say I start up. Oops. Up. I want to go through a horizontal. I want to go through a 30. And I want to go through a horizontal again. All right, well, I can do the mathematics of this, but look, there's something really easy. Anytime you see one step and then the very next step is perpendicular to it, you always get 0. So notice here I'm at 90, here I'm at 0. I'm going from this one to this one with nothing in between, and they're perpendicular to each other. That means no matter what else happens later on, it doesn't matter. At this point, I've cut off all the light, so nothing gets through. Now, if I wanted to do this formally mathematical, I'd say, well, it's I times the cosine squared of, I'm going from 90 to 0, so 90 minus 0 is 90. Then the next one, I'm now to the right. I'm at 0. I'm trying to go from 0 to 30, which is 30. Then I have a next one. So now I'm at 30. I'm trying to go from 30 to 0. That's 30 again. If I stick all this in my calculator, this is 0. So again, I get 0. So doing it purely mathematically, you get the right answer. However, a good time saver, if you know what you're doing, is to see that any time you have one step and then the very next step are perpendicular to each other, you will always block all the light and you'll have 0 left over. Try another example. We're up, we go through 30, we go through horizontal, and we go through 30. All right, well, first thing, it's not necessarily 0. Even though if you look, here's 90 and here's 0, they're perpendicular to each other. But this guy is in between. So this is not the time everything's cut off, because it's not one step and the very next step are perpendicular. There's a step in between. So we can't automatically say it's 0. Instead, we do the math. What do we have? I times cosine squared of. We're starting at 90 and we're going to 30. 90 minus 30 is 60. I'm now through that filter and I'm polarized at 30 degrees and I need to get through the next one. From 30, I'm going to 0. 30 minus 0 is 30. I'm now horizontal. To get through the next one, I'm going from 0 to 30. It's another 30. And there we go. Now all I have to do is stick all of this in my calculator. Cosine of 60 squared times cosine of 30 squared times cosine of 30 squared. And I get 0.141 times I. So notice, it's not, if you look at the system, there are two things perpendicular to each other that makes it 0. What makes it 0 is if two things that are perpendicular to each other are next to each other with nothing in between. Here, nothing's in between these two and they're perpendicular, thus it's 0. Here, these two are perpendicular, but something's between them, so I have to do the math. All right, another example. This time, what if we have what's called unpolarized light? Unpolarized light is shown like this, at least the way I do it. So the light is currently unpolarized. What it really means is it's polarized in random directions. There's not a set direction. How do I handle this if I try to go through this system? Okay. So I have unpolarized light. I want to go through vertically polarized and then 30 degrees polarized. What do I get? Well, if you remember the rule says if you start with unpolarized light, then no matter what the first filter is, no matter what it is, it's automatically a half. So for instance, we start with the original intensity. Our first thing is going from unpolarized, we're going through 90. Well, it doesn't matter that that's 90. All that matters is we start unpolarized, here's a filter, so the very first thing is 1/2. No cosine squared, no nothing like that, just 1/2. Now that we've done it, we're now through that filter and we're polarized up because it's an up polarized filter. And now I want to go from up to 30. So now I have a cosine squared. Because I'm not randomly polarized anymore, I'm now polarized up. So I go from 90, I'm going to 30. So 90 minus 30 is 60 degrees. And now this is what I stick in my calculator. So I have cosine of 60 squared times 1/2 gives me 0.125 I. So there we go. Unpolarized light, it's exactly the same method. You're still doing the law of malice. It's just that the very first filter is always 1/2. Not a half squared, just 1/2. Here's another example. Unpolarized light, we want to go through 60 degree. Then we want to go through vertical. Then we want to go through 30. Okay, so again, we start with the original intensity. The first thing, we're going from unpolarized to 60, automatically 1/2. Once we're through, what's happening? We're now at 60 degrees. We're starting with 60, and we want to go through this next filter. So there's a cosine squared. We're going from 60 to 90. 90 minus 60 is 30 degrees. Now we're through, and we're now vertically polarized. We're upwards. And we want to go from there through the last filter, which is 30. So we have another cosine squared. And this one is 90, trying to get to 30. 90 minus 30 is 60 degrees. And so here we go for our calculator. We have cosine of 30 squared times cosine of 60 squared times a half. I get 0.094 times I. So that's really all there is to this polarization thing. At the end of the day, these are the important pieces. Number one, unpolarized light always goes through the very first filter, no matter what angle it's at, with a 1/2. Once it goes through with that 1/2, you're now polarized in whatever direction the filter is. And from then on, you use your cosine squareds for each filter. If you're not unpolarized to begin with, you're polarized in a certain direction. In that case, the very first filter, you get a cosine squared. The angle for the cosine squareds is not what angle is the filter. The angle is what angle are you starting at currently, not at the very beginning of the problem. But once you've gotten through some filter, you're now at that new direction. So whatever that angle is, minus the angle you're trying to get to, you subtract them because you need the difference. That's the angle you put in a cosine squared. Once done, you're now polarized at this new angle that the filter says you're at. Lastly, a shortcut move that can be made is if you find that going through these filters at any point, if you're going from one point to the very, very next filter, and they're perpendicular to each other, then no matter what else happens in the problem, it's always 0. Okay, so that's like this example over here. The first example, or the second example, at some point we're vertically polarized, that's the beginning. And then we're trying to get through the very, very next step, happens to be horizontal. Well, vertical and horizontal are perpendicular to each other. So no matter what happens after that, doesn't matter, you're going to get 0 for your answer. However, the third example, at one point you're vertical, at some other point you're horizontal, so that's here and here. But notice it's not the very next point. There's a step between. That step between means we can no longer just say it's 0, you have to do the math. Now, if you don't like the shortcut, if you're afraid you might mess that part of it up, always do the math. Always put the cosine squareds down, and no matter what, you'll get the right answer. But if you want to save a little time, if you think you could do the rule correctly, then if you ever see an example like that, go ahead and just make it 0. You don't have to do the math for it. Anyway, I hope these example problems make sense and help you understand how to do this work correctly. It's really not that complicated, but you need to make sure you're doing the rules correctly because there are lots of places you can make little bitty small mistakes, like forgetting to square the cosines, or forgetting that the angle is not the angle of the filter, but the difference in angles, or the little 1/2 thing for unpolarized. If you can get those rules down, then this is a piece of cake. So practice it, because it'll be on your test for optics. So you want to make sure that when it is on the test, it's an easy question that you can get through really quickly. You don't want to mess up on these because it should be giveaway. Anyway, until next time.